Hi everybody, welcome to the Manifold channel. We're going to continue our series comparing workflow and processing speed of Manifold System Release 9 with Esri's ArcMap together with Spatial Analyst. That may seem like an unfair comparison between ArcMap plus Spatial Analyst is $5,250 per seat. What we're looking at here is ArcMap Standard Edition, which is $2,750, plus Spatial Analyst, which gives you all these nifty tools in the Spatial Analyst part of the toolbox. And that's an additional $2,500, whereas Manifold is under $500. In particular, the copy we're using is only $475. Be that as it may, we're going to be computing costs and paths using routing around barriers. And we're going to start with this image right here of Florida. It's a raster, terrain elevation raster that shows the Lake Wales Ridge region of Florida. That's 5,300 by 5,300 pixels. And we've created using set null this raster right here, which has certain parts of it knocked out with a value of greater than or equal to 40, to force the cost back length, the cost distance, and the path distance geoprocessing tools to route around that. And the equivalent in Manifold is right here. Here's the Manifold desktop. This is a $475 package that was acquired on sale. It's usually a bit more, but you can typically get it for under $500. And here's the exact same original starting raster, and I'm going to turn that off by double-clicking it. And here's the raster with the equivalent pixels knocked out. This is what we're going to use for our computations. And let's start by coming here into the equivalent of the toolbox. And there's all sorts of different tools here. I'm going to simplify those just down to the ones that have closest in their name, COLS. And the first one we're going to use is closest path direction. That's the equivalent to the cost back link. I don't want to use equal cost since we're going to be routing around these points. I'm going to simplify the name that it's going to generate, that it's going to use to generate the output raster. Click OK, and now I'm going to click Add Component, and it's going to take it all of about 3 seconds, maybe 3.2 seconds to run. That's considerably faster than the 25 seconds Arc will take to run. It created this raster right here. Manifold calls rasters, by the way, images. And to format this, if we formatted it using Manifold style, we could do it with a couple clicks, but I'm going to format it so it looks exactly the way the Esri image looked, and it will look when we create it. And what we want is the closest path direction image, which is right here. This is one that was created earlier, and you can see that what the coloring is like there. So I'm going to go into the properties, and I'm going to copy these properties for the color ramp and everything that was used. Click Cancel, and now I'm going to close this guy and go back here to my map. And for this, I want to copy on that image. Click the properties. I'm going to add a style pixel property, and for the value of that, I'm going to paste the JSON string that I copied out of the other one, and this is the JSON string that will color it exactly the way Esri colors it. So there's, if you've done a lot of work with Esri stuff, you know this is the kind of like the default forming that Esri tends to use for such path direction rasters. Okay, let's move on, and let's do the next geoprocessing tool that we're going to use. We're going to use closest path distance, which is right there. Use equal cost, and this is equivalent to cost distance, what Esri calls cost distance in the Spatial Analyst toolbox. And I'm going to simplify that name one more time. That looks good. Click Add Component, and once again, it's going to take it 3 seconds, maybe 3.5 seconds, and it's done. And what did it do this time? It created this image right here. I'm going to drag and drop that into the display. And now let's once more format that closest path distance image, which would be this guy here. This is one that was formatted Esri style. Off screen, I've selected properties. I'm going to copy that JSON string. It's nice that you can copy with a single click in Manifold. And here, open the properties, enter style pixel. Yes, I have to type this correctly. Style pixel. And paste that string. Like I say, you don't have to use this. You can use the point and click dialog if you want to use the default Manifold styles. And that shows you what the JSON string looks like. It's kind of convenient. You can do this in Manifold. And there you go. What this does is it shows the closest path distance, which means least cost path from each pixel in the raster to what is the nearest by least cost path green dot, and formatted the way Esri formatted to show all those different distances. I'm going to do one more thing here. The closest slope path distance, and here it is right there. And this is something that's going to take 7 seconds in Manifold, but it ends up taking closer to 8 or 9 minutes in Arc. So let's reduce the, simplify the name here. I like shorter names. Click OK. And when I click Add Component, by the way, I'm also going to take a look. I'm going to launch the Task Manager so we can see how many threads Manifold is going to use. Ready, set, all set. Ready, set, go. And you can see it as it opens up that it's running all 48 threads. We're running on a 24-core thread ripper, and it's done already. So there's not much of a blip, but it was enough time for Manifold to compute the graph, to dispatch 48 threads running in parallel to compute this slope product, and to do it super quick. And let's drag and drop that into there. And where's the slope path image? It's down here somewhere. Here it is. So let's click Properties, because we want to color this and make it beautiful. Let's copy that JSON string, cancel, come back up here, Properties, add Style Pixel. I guess I should do one of these with the regular Manifold style dialog, so you can see how quick and easy it is to do it with Manifold when we use the default Manifold styles instead of deliberately trying to duplicate the Esri styles. And there we see the slope path distances routing around these barriers. What the slope path distances do in Manifold, that's equivalent to using path distance with a vertical factor. And what this does is it automatically computes on the fly internally the slope for each and every one of these raster pixels. And then it computes the least cost path distance by reckoning that when you're going downhill, the cost is lower than when you're going uphill. That, of course, makes sense. But that does mean that you have to, I guess, anisotropically compute asymmetrically compute the directionality of each of the paths to know whether you're going uphill or downhill on a slope. So that's a larger calculation, and that's why it takes this calculation 7 seconds to run instead of 3.5 seconds to run. Like I say, it's going to take ARC about 8 minutes to do that. We're not going to hang around to watch the whole thing. We're going to simplify this. Let's see how fast ARC can do all the equivalent things. Let's start with down here the cost backlink. And for the cost backlink, we're going to start with the Florida drawing. Those are our features. Those green dots. And the input cost raster is going to be the Florida grid. No, excuse me, it's not the Florida grid. It's going to be this cost barrier grid. And that looks right. Yes, all set to go. Okay, fire away. Now, the good news is that ARC can do these kinds of computations much faster than it can do other sorts of things. And so instead of sitting around here for 2 minutes, we're only going to be sitting around here watching and talking about this for anywhere from 20 to 30 seconds, typically about 22, 23 seconds, something like that. And it's wait for it. It's there. It's running in the background. It's doing everything that it needs to do. It's doing a great job here so far. And there it succeeded. And that took it 26 seconds. That's slightly slower than normal, but it's in the ballpark. And to compare what Manifold created, that was the direction image. And there's the direction image, and here's the direction image from ARC. So let's go straight to the next one, because we don't have a whole lot of time here for the video. And the next thing we're going to do is we're going to do the cost distance. The cost distance is also pretty quick in ArcMap. Again, we're going to use the Florida drawing as the feature source data. Again, we're going to use the cost barrier grid that we computed to knock out a few pixels. And let's click OK. And this one is also going to be quick. One of the things I really like about ArcMap, by the way, is how it reports these the environments and the messages. We are using, let's see, 100% parallel processing environment, which means that ARC is making so many decisions. It launched both of these things in 9 parallel instances. And what's going on here is that ArcMap itself is actually dual-threaded. It's running this geoprocessing tool in the background there, and it's done. And that took it 27 seconds. And let's come back here to Manifold. And that's the one we created in Manifold. So you can see the two are the same. The difference is that Manifold did it in 3 seconds, and ARC took, whatever it is, 27 seconds. What would it take? 27 seconds. All right. Last but not least, let's compute the path distance, or more accurately, let's get the path distance started. We're not going to wait for the path distance to finish, because that's too much to ask of people to sit here and watch ARC do nothing for 8 or 9 minutes. So let's click path distance. The input feature is going to be the Florida drawing. And this is where it gets a little tricky. I got to remember how to work all this stuff. The input surface raster is going to be this cost barrier grid, and the vertical raster is also going to be the cost barrier grid. And the vertical vac factor you have to set manually, and ARC is going to be linear. That's actually not bad because it gives some options. So that's I don't mean to say that as if it was a slam or anything. It's not. It's a cool thing. And that looks like it's all right. I want to double check this because, when you got to wait 8 or 9 minutes for this thing to cook, you don't want to make any mistakes. With Manifold, if you make any mistakes, it's no big deal because it takes 3 seconds. You can just redo it. All right, off to the races. And path distance, let's see what it's come up as. It's just also distributing across 9 parallel instances. I want to emphasize with a parallel processing environment of 100% in the factor, this is ArcMap and the geoprocessing tools that are individually making their own decisions how many threads they want to use. The way ArcMap and ArcGIS Pro, also architecture, work is that these are both basically dual-threaded. They're not single-threaded applications, as is commonly stated. They're actually 2 threads because they can run something in the background. Like you can see here, we can continue working with the user interface while a tool is running in the background. It can't do anything else in the background. It can't run another tool until this one is done. But it can at least maintain the front. Now, all the parallel processing is right here in this tool, which is the path distance tool. And when you look in the catalog of all these different tools, Esri has parallelized, I think, something like 80 of them, maybe 90 of them. And some are better parallel than others. And but in this case, as you can see, they're all kind of limiting. They're all topping out at about 8 or 9, about 9 threads, where Manifold is running for all 48 threads. That's one reason why Manifold can do this calculation that we're waiting here for, that Manifold did the calculation in 7 seconds, while this is going to take about 8 minutes. We can safely go into Manifold here without mucking up the works and take a look at the log. How long did Manifold take for all this? It took 7.2 seconds for it's going to take Esri Spatial Analyst over 8 minutes. Before that, the path distance it did in 3.4 seconds. Before that, the path direction did 3.29 seconds. So those are all substantially faster, typically running 7 or 8 times faster, or in this case about 70 times faster than what ARC is doing. And why is it so much faster? It's because there's several reasons. First, Manifold itself is a 100% parallel application. Everything that it's doing here is parallel. So when it's talking to these various things that it's running, it's doing all that in parallel. And by the way, in case anybody thinks I'm mucking up how fast ArcMap is working, I'm not. As you saw, we're working here on a thread ripper that has 24 cores with 48 threads. If ARC is only using 9 of them, that's leaving how many? 39 threads for us to do whatever else we want. We could be watching Netflix on this, and it wouldn't affect ARC because there's so many extra cores to use. So ARC is simply using the resources that it deems best to use. Now, why is this taking 8 minutes in ARC that only takes 7 seconds in Manifold? There's primarily 3 reasons. The first is that ArcMap itself is really single-threaded except for what it's dispatching. So even though the parallelized module is running parallel, it's kind of like an 8-lane highway where to get on and off the 8-lane highway, you got to use a single-lane on and off ramp, which is what the ArcMap application is. So there's a lot of traffic jams in that single lane. And so you spend time in the traffic jam to get on the 8-lane highway, you run a few miles in the 8-lane highway, and then you spend a traffic jam to get off. And that's a big delay. That's the first thing. The second thing is that these tools aren't particularly well parallelized. It's only running 9 parallel instances when it could be running 48. Why is it doing that? It's because it's rather difficult to launch so many parallel threads and without those different parallel threads stepping on each other. You can actually run much slower if you run too many parallel threads, if your parallelization isn't all that well. Esri basically has first-generation parallelization here. It's the sort of thing that Manifold was doing 15 years ago. And in the ensuing 15 years, there's a lot of know-how which has enabled Manifold to run a whole lot faster, with the 48 threads, which Esri simply isn't doing. The third reason why Manifold does all this stuff in 7 seconds, which takes Esri, in this particular case, 8 minutes, is that the storage that Esri is using is very slow. It's GDB. And GDB is kind of a Rube Goldberg database technology. It's not particularly parallel-friendly, whereas Manifold stores everything in Manifold's native Radian.map, Radian Database Engine.map format, which is unbelievably fast. It's actually faster than things like, say, Postgres, which is a very fast database. And it's actually extremely well parallelized. It was designed for spatial parallelism from the ground up. So when you combine those 3 factors, having a 100% parallel application that talks to very well and very effectively parallelized tools, and stores everything in a highly parallel-friendly storage environment, that really does end up being 70 times faster than if you have a single-threaded application that dispatches to, kind of outsources to a parallel tool, which is parallelized only in terms of first-generation parallelism, not all that comprehensively done, let's say, and which uses a very slow, non-parallel data storage. And you can put all that together, and you get this taking 8 minutes instead of 3 seconds. This started, let's see about that. So we still got, at least 4 or 5 minutes to go. I'm going to pause this video. I'm going to spare everybody having to look at this thing, Arc do nothing while we're waiting around. And I will volunteer to wait around and stare at this thing do nothing for another 4 to 5 minutes. And when it comes back, I will unpause the video and we'll see how long it actually took. So hang in there. Ready, set, pause. Well, here we are. We're back. And that was a long 4 or 5 minutes. I don't know how long it was, but trust me, when you're sitting here looking at the screen not doing anything, it's tedious. And how long did this take? Let's see. It took total elapsed time 8 minutes and 15 seconds, and it created the same raster that we see here in Manifold. Let's see. Slow path. There it is. And that took us what? That took us 7 seconds. So I hope you've enjoyed this video. We've seen how the different tools work. The next video is going to be something really cool. That's the Euclidean path distances, which are working around barriers, which Esri is justifiably very proud of. And we'll compare those next. In the meantime, thank you for watching. I hope you've enjoyed the videos, and goodbye from the Manifold channel. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.